Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled The Large Magellanic Cloud. So what do we see here? Well, here we see an image of one of the nearest galaxies to us, and that is known as the Large Magellanic Cloud. Now, this is actually easily visible to the unaided eye as long as you are far enough south. Because it is very far south in the sky, so for those of us who live in the northern hemisphere, well north of the equator, it's invisible. It never gets above the horizon because of its positioning in the sky. So no matter how hard we look, we'll never be able to see it. However, if you go toward the equator, and in fact, as long as you're south of about latitude of 20 degrees, you can see this in the sky. Easiest to see if you're in a relatively dark location and not near a big city and other sources of light pollution, but it is the galaxy that you can see with the unaided eye and a little easier to see than Andromeda, which although much larger than the Large Magellanic Cloud, is much farther away and therefore much harder to see in the sky. If you know where to look and you have a dark sight, you can see that as well, but nowhere near as prominent as you would see this one. Now, this is a small galaxy known as a dwarf irregular galaxy. Dwarf because it's a small galaxy, irregular because it doesn't have any specific structure to it. So it does have some signs of star formation like our own Milky Way, but not in the ordered spiral pattern that we see within a much larger galaxy. And in fact, it's often thought that this type of galaxy are the ones that first formed after the universe did billions of years ago. At that point, galaxies tended to be small and irregularly shaped, and it wasn't for billions of years that they slowly evolved through mergers into the large spiral and elliptical galaxies that we see today. So this has a mass only about 1/10 that of our own Milky Way, but it is still undergoing vast amounts of star formation, and we can see a lot of those star clusters present around there as well. A lot of this star formation could be due to our own Milky Way galaxy and how it tugs at the Large Magellanic Cloud, twisting and turning it, causing gas clouds to collide together and enhancing the rate of star formation. Now, this is also the location of the nearest supernova to have occurred recently, and that is supernova 1987A. It is the nearest supernova since the advent of the telescope. So we have not had one in our galaxy. This was the closest one. It has been a very exciting one for astronomers over the past few decades, as it gave us a chance for the very first time since the telescope had been invented to study an exploding star up close. Why was that important? Well, we have plenty of pictures of the Magellanic Cloud at that point, and we could actually identify the original star that became the supernova. That's not something we can do in another galaxy. We don't see the individual stars there, so we can't go back and look and see what star that it was that became the supernova. And that was very interesting, helping us to better understand the process by which a massive star can explode at the end of its life. So that was our picture of the day, titled The Large Magellanic Cloud. We'll be back again tomorrow for the next picture, previewed to be 185 AD. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.